Alrighty, we are live here at the Dino Lab at the Natural History Museum of Los Angeles County, and this is Doug Goodrow.
Hi.
So Doug, what do you do, and where are we standing?
We are standing in front of the Dino Lab for the Dinosaur Institute at the Natural History Museum, and I prepare fossils and manage this lab. And so I'm going to show you what we do from when we bring field material in from the field and get it prepped for display or for research.
Fantastic. Well, let's go.
Okay, come on in. So here's something I'm working on that we'll get back to. We're going to go over and look at the quarry map first so you can kind of see where this material came from. Okay, follow me. All right. This is our quarry map. This is from Blanding, Utah, where we've been working the past few summers. As you're zooming in there, you might see the little dots that represent 1 meter by 1 meter squares. And we have what we call a lower quarry, this being a hillside, if you can imagine, looking down from a bird's eye view. The hillside would go through here, and this material has slumped down, and just a few meters away we found some other material that's still in situ. And the more we go into this hill, the more overburden we have, but of course the more protected the material is, that it hasn't been eroded out, the better shape it's in. And so we keep finding more as we go into this hill. And these different squares represent different levels, if that makes any sense. It's kind of hard to get an overall perspective.
Okay, so you find the fossils, and then what do you do with them in the field?
Well, as we uncover them, we try to jacket them, encase them in plaster and burlap in small enough units that we can handle easily and pack in a U-Haul and get them back to the lab so that we can take our time preparing them in greater detail and separating the different elements out. Sometimes even finding more smaller bones in and amongst the jackets. When we collect a specimen, we'll find multiple other things in the surrounding matrix that's included in the jacket. So we're going to prep that out, dig this up, get it back to the museum, and spend the rest of the year doing that detailed work.
And that detailed work means that you are, filling them and repairing them to be sometimes displayed and sometimes for research?
Correct, yes. We can look at some examples of that because there's a number of specimens from this quarry map that are in the different states of being prepared out. And one good example is behind me over here. We'll go look at this femur. This is a good example from this lower quarry. It's a good size.
Let's see some fossils.
All right. So this is nearly complete. It's actually been removed from the jacket, and this is from the Natalie quarry. We're calling that Natalie from all the gnats that were biting us. That's the field name in previous field seasons. So we go out there in the hottest, driest part of the year to avoid the gnats, but the name stuck, and this is part of that quarry, and we're thinking this is probably chimerosaurid femur, not so much the diplodocid that makes up most of Natalie. So there's several different individuals at this particular site, and this is one femur, like I said, an isolated femur, jumbled up with a bunch of other bones that has been flipped over, cut out of the jacket, and now we've prepared the other side. So in doing that, we use zip scribes and aerobrators and then putty to fill the cracks. Oh, I forgot one good thing is as we're uncovering the bone, it would become destabilized and crumble apart. So as we uncover the bone, we add acryloid, this glue here, and it's a mixture of acetone and a polymer. And it's kind of a clear, we can maybe trip a little bit out here. It's just a kind of a clear, kind of drippy fluid And we can make a different consistency. So sometimes it'll be thick and it'll fill in gaps, or we can make it real thin that it'll penetrate, the acetone evaporates out, and really stabilizes that bone really well. Larger gaps that we can't fill with glue, we'll go in with a 2-part epoxy putty and fill that in. So we have a nice stable unit and get it ready for making a mold of it.
So one of our viewers thinks that this is a tree. Can you talk about, maybe mention again?
Well, it is tree size. It looks like a tree trunk if you've ever been to the petrified forest. That fossilized material will break in the same way, kind of in these sections. It'll start falling apart if that's not stabilized. But what makes the bone different from the other fossil material is you can see the texture. I don't know if you can get up close enough to see the texture and the features of very similar to our own skeletal systems. So you have foramina and muscle attachment scars and pathologies, other features like that stand out once you start removing that dirt, and it becomes a little more apparent what's bone and what's not.
So how come this bone is green?
That's kind of a fun fact there. There's a lot of different minerals that influence the colors of the bone, and some of those predominant minerals are decomposing copper, malachite. Some of that red, of course, on the end would be the iron. That's why iron-rich soils around, and uranium, and a number of other things that also influence the color. Because there's hardly any bone left. Most of it's been mineralized with all the surrounding sand. It's kind of a gray-green color as well. So that influences the color quite a bit. Some of these sections, if they break open, they're opalized inside. So there's kind of an iridescent red or yellow opal material in between a lot of these sections of bone. But I don't have an example of that right here, but some of the vertebrae do have.
Okay. What else do you have hanging out in here?
What else or who else?
What else or who else? What other creatures
Tony,
that are alive?
Yeah, Tony is a volunteer here in the lab, and he is working on some different fragments of different ribs and things that were found in and around that femur jacket that were, you can't help it. Once you start trying to trench around a bone, you'll find more bone. And so some of these elements that are broken up pretty badly, what should I say? They're not insignificant. They're in situ with the bone. So rather, if somebody wants to do any kind of micro studies, they can take a core sample from this and not bother our nice pristine femur over there.
Sure. So since this is a research institution, we save extra parts so that people could do research on these smaller specimens rather than taking apart, the large articulated portion.
Sure, that's a good way to put it. And Tony, did you have something to
what do you
say
have
there?
Just working on a few fragmentary materials, make them pretty for research and collections, and they're not hugely consequential to the research yet, but who knows, maybe farther down the line we get a fresh pair of eyes looking at these. Could be a skull fragment, could be segments of teeth, who knows? That's what's exciting about the research. Always changing.
So you don't know what this guy is?
Not necessarily. It's unidentified material. We do have bone surface though, so it's a lot of surface fragments of probably something larger, very thin bone, so maybe the part of the spinal column maybe.
Huh. Interesting. So how do you guys work on preparing something like that? Like, I see you sitting at this station here.
Well,
What's
we
that
have
about?
many different tools to trade. We have various zip scribes. You can kind of think of this like a pencil-sized jackhammer, all powered by air that vibrates the tip, chips away at the matrix, which is the rock surrounding the fossil. And then, like Doug was saying, we have various thicknesses of acryloid, which is glue. Very, very important to a fossil preparator. And of course, all the little tools for the little fossils, like the dental picks. We use acetone to clean off some of the bones, and of course, toothbrushes. Brush your teeth, kids.
Brush your dinosaur teeth.
Yeah, so we start off with the manual tools first, and then go heavier with the zip scribes, like Tony mentioned. And
Cool.
then we have great big monster ones, all the way up to jackhammers that we use in the field to get that that bone out of the ground first, and then go back with other tools to do the fine tuning.
All right.
Here's a good example of a bone we don't know exactly what that is. So it started off, we thought we had a kind of a broad chevron here. That's the field top. And then once we prepare that, flip that over, this is the field bottom. So some interesting features there.
Huh. If any of you out there have any thoughts on what this bone is, let us know.
Possibly a skull fragment, since we have 4 to 6 different individual sauropods at this locality, and no skulls, no complete skulls yet. We have found the beginnings of a theropod skull, a small allosaurid type of animal, but this might possibly belong to that. Possibly a spine would come off of there, but not sure yet. Some very beat up chevrons. These are kind of an A form, if you can see that. Imagine the matrix being removed there. But this would go underneath articulate with underneath the tail, underneath the centrums of the caudal vertebrae. And this is largely a lot of iron in there, so it's a little more red than the green that's typical of the material.
Excellent. So, thank you, Tony.
No problem.
It
So
looks
we
like
can-
we do have some vertebra over here.
Yeah, this is a more complete caudal vertebrae or tail vertebrae nearing the end of the tail. And just a side note, this material is so green. This is typically what you might find out in Utah in the Morrison Formation, that being 150 million years old or so.
He said 150 million, just to be,
Yes, yeah,
just to have some idea. Of,
give or take a million. Yeah. So that's just a ballpark, but Morrison Formation. But typically the material is kind of a black or almost white, like the bone that you see here. In this case, there's this really thick iron coating. That's really a bear to get off of the surface, but we're managing that. So this is more of a chimerosaur that's found only 15 miles away. So just based on the mineral concentrations in the ground that naturally occur, that really influences the color of the bone, you can see.
wow. And so is this what something looks like when it's finally prepped and cleaned up by
that's
your
the
team.
end result, right.
It's beautiful. Yeah, they
Yes,
don't find them in the ground like this, guys. All
So
right.
Robert is working on something
What is Robert working on?
It's another vert. It's a anterior caudal vert, but it's kind of like a portion, a slice of one. I just started this the other day. So this was 2 days ago. Was just a big mass of concretion, and now there's the fossil coming through there. There's the spine. There's the top half, and this is the field bottom of the jacket. So I'll be making a new cover and flipping it over and continuing around.
You make a new cover when you finish prepping this side?
Yeah, usually like we'll flip it and make a new holder for that end, then finish off the other side.
Yeah, often the holder and cast are one and the same. You're basically making another jacket over
So-
that side to protect it, putting some tissue paper over it, then putting plaster burlap over that, and then flipping it over into that. And you notice the sandbags that are in the booth as well, that help absorb some of that vibration, allow us to pose the specimen in such a way it's protected, but then we can attack it from every angle to get that prepped thoroughly.
And that's in the zip scribe, one of the tools we use. It vibrates like a little.
That one's a little more gentle than the one he was using. And we even have smaller ones or larger ones as well. And you'll
Wow.
notice too, we have everything in these booths. It's all about containing that mess and that dust, as well as keeping the air
Yes,
being
everyone
filtered.
can see.
So we have the machines in the lab, the dust collectors in the lab, off right now because the roar of those kind of makes it hard to film. But it's real important to keep the air contained and filtered and basically channeled out of the lab, and keeping the dust contained as well. So lots of cleaning. It's a dirty job that involves lots of cleaning and maintenance to stay on top of.
That's
So
great.
larger. So when we're done doing the zip scribing, Robert would then take this over into this booth over here. We do the air braiding. And some of you out there might have seen one of these. It's basically a miniature sandblaster. And so this is a little pin-held instrument that this is a foot pedal operated. So you press on the pedal and sand blasts out of there. We'll use different types of sand depending on how hard the matrix is. This is pretty tough stuff most of the time, lots of metals in it. So we'll use aluminum oxide and a sodium bicarbonate baking soda mix of those two. And then this is also, like the zip scribes, is hooked up to a air compressor. So it's partially pneumatic. And then that'll blast the fine sand and knock off whatever else the zip scribes don't get, or get into the details that we can't get the tip of the zip scribe into. So that's done in this larger booth to contain that mess, because there's another level of dust you don't want to be breathing. And we have lots of space to spread things out. A couple of folks working on, again, more vertebrae. So there's these are big animals. Well, there's the orangey brown silhouette outside the lab. Is a kind of a small.
Yeah, we can sort of see that.
It's just it serves as a model to see it. The size.
Yeah.
This would be a small sauropod outside the lab to take up that whole wall.
So so they have a lot of vertebrae.
Yeah, so there's no end to the amount of vertebrae we're finding, and then with so many different individuals in the same place.
So some of our viewers are asking what they are, and it's a kind of sauropod, but we haven't identified any more specific than that.
It's a diplodocid, but
Okay.
with other friends in the at the crime scene. There's some Camarasaur, mostly diplodocid, and we have folks helping us to identify those things. We even have some theropod material there.
And for those who may not be familiar, like what's a famous theropod?
Oh, well, this would be an allosaur. This is the precursor to T-Rex. So before there were T-Rexes running around, there's about something half that size, but a formidable predator nonetheless.
Do we have one of those?
We don't have. There's another good femur if you want to take a look inside.
Ooh.
Not a femur, vertebrae.
Vertebrae?
There's the putty stages that Erica's not here today, but she was working on puttying that centrum. So that putty fills in that large gap there.
And so how old are these fossils?
These are all in that same Morrison formation, that 150 million year ballpark.
Great.
There's more iron on that centrum. And we have different types of lighting to see the matrix. Sometimes your eyes get a little strained, and when you're looking at something for a while, you shine a different type of lighting on it, and it reveals there's still a lot more to remove, or you can different minerals will show up a little bit better with a change in the angle of lighting or type of lighting. So you have a number of different lights in there for that.
And to answer some of your questions about whether or not we're affiliated with the tar pits, and the La Brea tar pits, we are. So some of our preparators from the tar pits came on the dinosaur dig this last season in Utah. However, just to be clear, for those of you out there, the tar pits themselves we don't find dinosaurs in the tar pits, but we do find them at our sites in Utah and New Mexico.
Right.
And so that's
The tar pits are way too young.
Yeah, the tar pits are, 40,000 years old, and we're talking about 150 million years in here. So what did we have in here?
You're asking about theropods. So this is, it looks a little bit like a jumbled mess, but the closer you look, if you can look down here where my fingers are, these are actually teeth, and this is part of the maxilla, this little section, and this kind of arcs back here. Sometimes it's really just to make it clearer for us to work on. we'll print out something. This is a copy of a publication of an allosauride. And so we're thinking of, we're looking at parts of a maxilla and parts of the posterior sections of the skull, possibly.
Wow.
So we have these different elements. They look like a bunch of boomerangs that all interconnect toward the end of the back of the skull.
So these
Plus this
parts
portion
that
of
we
them.
think maybe are teeth here. Oh, now we can see maybe. Yeah.
Does that read well on your camera? Yeah. Yeah, so this would be a tooth here. So noticeably smaller than a T-Rex, where the teeth can be nearly a foot long from tip to root. So this would be a big predator, closely related to a T-Rex.
Okay.
Some more different types of lighting.
So yes, so as you were talking about the different kinds of lighting, you can see here we're doing some different.
And it looks really cool to the public because you can see all of what we're doing in the public, from the public perspective right outside.
There's no one out there right now because it's lunchtime, but oftentimes there will be children right where that reflection is.
It's nice when you get a break from that.
So these are priceless specimens, we should say.
Yes, that's a good point. So sometimes you think you know what you're working on. You got to be careful because some of the tools we use could also cause damage if you're not really careful. So it takes a bit of training the eye when you go to a new locality to get familiar with what is bone and what is not. And here, this is the pelvic girdle. So that's a large portion of the pelvis, pubis, sacrum, ischium are all jumbled up together in this jacket. And I know that because I helped dig this out of the ground and get it back here. And we have flipped this over. So what we're looking at is the field bottom. If a sauropod died and fell over on you, this is what you'd be looking up at. and so there's some additional bones articulated in here, some rib sections and things that I didn't know were in here. So we dig around the bones out in the field to make sure you include everything and leave some matrix on there. Matrix, I mean any dirt and sand and rock. Leave some of that on there that also to protect the package until we get it back here for safe cleaning. So yeah, this is another type of zip scribe here, and this is really especially good on blasting away this this really heavy sandstone and concretion that's in and around this specimen. So it gets really compact by all the overburden bearing down on it for millions of years. So it is really cemented and really hard to get out.
So how do you get it out? How do you cast it while it's in the ground out in the field?
Well, we came across, I think, the hip, part of a hip bone, and that's now on the other side here.
So yeah, so everyone can see how big this jacket is. And we call these jackets these large plaster packages full of...
Yeah, I want to get the proper orientation. I believe the hips are splayed out like this, and so part of the pubis is jutting up and out here, and the sacrum is now, the spines of the sacrum are underneath here where my hand is. It's kind of hard to make. You have to use your imagination a lot, but you can see we had to we used some metal rebar and conduit to strengthen the jacket, kind of splinting, like splinting your arm if you had a broken arm. And then we cut that open from the other side, got as much prepared as we could on that side, and then we flipped it over, and we used a hoist upstairs to do that. And we had to reinforce it with lots of rebar and then a metal frame that Carl, another preparator, welded to give that further support and also make it a flat square. It was a really unwieldy, uneven object, so we had to make it to make it more accessible and preparator friendly. and viewer friendly, we were able to put a big frame on the other side and then flip it onto that. So it's really stable, and we can nice to display on the half shell, if you will, and also access. So
How heavy do you think it was, ballpark?
this I do not know. It was nearing a ton at first. A lot of this matrix has been removed down here, and then a lot from up here. This is trimmed down significantly. So it was on the border of a ton or so. We know that the femur back there that I showed you is about 640 pounds because we were camped in Utah right next to a landfill. So you could pull up a truck that goes in to dump its load, and they weigh it after, and then they charge you accordingly. So they volunteered to weigh our femur for us. So if you add the dirt and the plaster jacket that we put on, it was about 640 pounds, give or take a few pounds. So that's just to give you an idea of how heavy some of these jackets are. Ideally, we'd want to make it a smaller package, but getting in there with just the summertime window that we have, this is the smallest we could make this. Because then the problem becomes you have this nice big jacket, but how do you get it into the truck, especially a rental truck? You don't want to damage that. And it's a real trick to just pack these jackets up into a U-Haul. And sometimes you have to rent a forklift or other heavy equipment to do that part of the process. But nonetheless, we got it back here in the back of a pickup truck, and then with several extra hands, got it onto a cart and went into the lab.
So now that it's back here, we had a question saying, how do you know the difference between what's rock and what's bone? Is that just over time you have experience?
Yeah, you have to develop an eye. You can see some of the, I don't know if your camera can pick up some of the striations here, the texture of the bone. There's a porous, if you see where my hand is tucked, maybe you can, we have this homemade booth here, so we can contain this. So yeah, I think you can see without too much of the reflection.
Yeah.
This porous surface where normally there'd be a cartilage cap there that helps articulate with other bones. So you can see that texture there is different, and the color is slightly different. If you can put the light on there, where the sandy matrix has a rough, kind of a rough texture with clay nodules mixed in with it, and then it comes away pretty readily. Should I can maybe I can close this and put my booth down.
Do a little demonstration.
Oh, I think the air is turned off, or just my.
No.
I had it unplugged from the. We have to have a filter connected to these too, because too much moisture comes through the lines of the air compressor. So this kind of makes a hum. And you can see that this kind of vibrates and beats back and forth like a little mini jackhammer. And this is being pretty cooperative. This is actually a nice a nice spot to demonstrate. And air blows out of that and kind of pushes away those little bits of dirt.
So this is definitely painstaking work. It's little bit by little bit. And how long does it usually take you? Thank you for demonstrating.
Sure,
by the way.
you bet.
How long does it take you to do a fossil of this size? Like, how long do you think it would take to prep this pubis?
Well, we have several projects going on at the same time, as well as doing tours and things like this. So it takes a little bit longer, but never having prepped out a whole sauropod, sacrum, and pelvic girdle, I'd say it'd take the better part of a year, or maybe more, depending on what else we find in there. To get it out of there and totally separated and prepared into different holders, yeah, probably a year, maybe two. We'll give it somewhere in that range. Just because there's so much detailed work that you don't know. There might be something significant in there that we want to stop and make a mold of, and then send a copy to another museum or institution for further study. Or we might also get something else that in here that's more of a priority. in that we have some other localities with other skulls and things that we might want to get to first and put this on hold, but nonetheless keep working on it. Maybe have some volunteers help us with it too. So it's kind of a tag team effort.
So you share with other institutions.
Yes.
That's really neat.
It's really
and do other people send you specimens to look at? Does that help your work?
Yeah, we either go to different places and make molds and casts of specimens, or other folks help us. The Museum of the Rockies helped us with our T-Rex. They wanted to study the femurs of our T-Rex for a growth study, and so they had to cut in and take a sample of that femur. So in the deal was we would let them prepare it out, and they found a couple of their toe bones in there with that, so making our T-Rex more complete than we thought. And so we make deals like that all the time. Yeah.
So do you have a cast that you've done recently?
A cast? Yes, we have a touch specimen that we did just for fun for kids.
So what does it look like?
Well, it looks exactly like the real thing, but what we do is this is a little touch specimen of a piece of real bone that
So
was
this is a cast.
disarticulated. No, this is actual real bone.
Oh, this is real bone.
That we just made, but that was here. This is going to be kind of a touch specimen package. We have some real bone, but then a complete mold of a caudal vertebrae. And what we do is we put the bone when we finish preparing it, put it in the sand, then pour a liquid rubber over it, and then make a jacket of that plaster and burlap over it. And that way the plaster jacket, or mother mold we call it, helps kind of cradle this flexible rubber part. And so we can go back and look at, I think it's in the other booth over here. Oh, thank you. Yeah. So we just have that in here. So that's a copy. You can tell I've taken some resin and paints and dyes or tints mixed in with the resin, and some epoxy putty to make up what looks kind of like the mottled green appearance. It's got a little dust on it too. Everything gets dirty in here. So it has that kind of mottled green appearance that will be out there for kids to kind of touch and get the sense of where we're going with these jackets that we're preparing out. So
yeah, if you didn't tell me this wasn't a real fossil, I would have no idea. You guys do an amazing job here.
We are that good. So that's from beginning to end.
Like if you put it next to this real guy over here.
Actually, this is a part of the pubis from that larger jacket. So that was part of that same specimen that I just got done showing you the demo on. So yeah, if you put that near that, how's that read on film? Pretty? Is that pretty close?
Yeah.
You have all the greens and the reds all matching up.
That's wonderful. So
yeah, it's really pretty.
For those who've
material.
just joined us, we're showing you this one on your left is a cast that our paleo team has made for kids, in an education setting, and on the right is a real sauropod fossil. So that's some of the other work that you guys do here.
Right. We work closely with the exhibits team to make the mounts and get the fossils out there and safely displayed as best as possible. Okay. There's fun little models there from that. So what else? Is there anything else you want to take a look at?
Do you have any parting words from your team?
Dinosaurs are cool. You can quote me on that. Tony Turner, 2015.
Oh, we can look at a couple of boxes of material that is complete and is going to our collections for the time being. This is one toe bone. I forget which digit that is. Some other caudal vertebrae.
Wait,
that's one toe.
This is a toe?
Yes, yeah. Look at that. For scale.
Wow.
So, and then a series of tail vertebrae. if you look over here, this is another toe. They kind of had a claw that stuck out, I think, inward. Not really a thumb, but this would be kind of a claw, and then more vertebrae. Sometimes you can see these processes break off, and then sometimes we'll have one in and leave that attached for the time being. We can always clean that up and take that off. And
Great.
yeah, progress photos that go in our collection as well.
Slideshow of the field, you guys in the field building on.
Yeah, just to remember where they came from, they have a slideshow here of what it takes to dig in the desert for a month at a time.
Jackhammering some of the material out. So you have to stop and check and make sure you're not going through anything important. And then we have little handheld air guns to get into tight crevices. Oh, that's actually those are the hips of the sacrum. I mean the pelvic jacket that we used to cut. Things that we don't collect that year, we cap it or put a protective jacket.
Yeah, so that white is plaster out in the desert.
Right. So that's to protect. We got to cover up the area that we worked in, and that we can't always get to everything that we uncover. We are loading some things into a truck, and so that's a specimen that's trenched. That's already all the forearm bones, the forelimb bones, and that's trenched. Now it's jacketed there. That's a vertebrae that's jacketed and trenched around. And
Great.
and we can look at photos all day.
All right. Well, thank you all so much for letting us come into the Dinosaur Lab at the Natural History Museum in Los Angeles. You guys can come see these guys. They, as we mentioned, there's a window where we let them see out while they work, and you guys can come see them working on this stuff every day.
Yeah. Please come by. Looking forward to seeing you.
All right.